Good morning, everyone. Welcome to assignment 12, solving logarithmic equations. This is another lesson where you should look at the handout first, maybe print it out if you can. There's a do now on it where we're just going to practice going back and forth between log form and exponential form because that is key skill to have for today's lesson. So without further ado, here we go. So hopefully you've printed out your sheet already. If not, pause the video, please do so, or at least copy down on a separate piece of paper or whatever. Just start working on the do now. I'm going to go over the first do now first. So if you haven't done it yet, just pause the video and try the do now. So this one says to write each equation in logarithmic form. Here it's in exponential form. The best way to do it is if we have the exponential term to the left, just do our little lasso, and it becomes log base 2 of 16 is equal to 4. That means that 2 to the 4th power is 16. For letter B, we're starting at 12. We're looping all the way around and going through that 1 to the 0, and it becomes the log base of 12 of 1 is equal to 0. That means 0 is the exponent of 12 that yields an answer of 1, meaning 12 to the power of 0 equals 1. The first one is log base 2 of 16 equals 4. 4 is the exponent of 2 that gives an answer of 16. That's how logs work. For the third one, we have the log, the base is 5, of 0.008 is equal to negative 3. Hopefully you could read that. It's not easy to write on here. It says log base 5 of 0.008 equals negative 3. Negative 3 is the exponent of 5 that gives an answer of 0.008. Remember, a logarithm just is an exponent. That's what it means. And then the last one, letter D, is the log base is 64 of 4 equals 1/3. Log base 64 of 4 is equal to 1/3. So there's your first do now. All right, for the second do now question, we have to convert from log form to exponential form. So again, we just do the lasso. So for A, since the log expression is on the left-hand side of the equation, we start at the 10 and we loop all the way around, and it just becomes 10 squared, 10 to the second power is equal to 100. Okay. For the second one, however, you'll notice it's written backwards. It's 7 equals the log base 2 of 128. So if you want, you can rewrite it the other way around or just draw your lasso in the other direction. So now it'll start at the 2, it'll loop around the 7 and end up pointing at that 128. And it becomes 2 to the 7th power is equal to 128. For our third one, log base 10 of 0.001 is equal to negative 3. So we loop around. That just becomes 10 to the negative 3rd power is equal to 0.001. And finally, for D, we have log base 8 of 2 is equal to 1/3. We loop around again, and we get 8 to the 1/3 power is equal to 2. Remember, 8 to the 1/3 power just means the cube root of 8. For the third question, you need to evaluate each log below. Basically, it just means write what it's equal to. So the first one says log base 8 of 8. And in your mind, you're thinking, all right, what is the exponent that I can give to that base of 8 that'll make it equal to 8? So you're kind of thinking, well, 8 to what power is equal to 8? And, well, it's clearly just going to be 1 because 8 to the 1st power is equal to 8. So the next one says 4 log base 6 of 36. So you got to think of this as, well, what's the operation going on between the 4 and the log base 6 of 36? Well, that's multiplication. So first thing we're going to do is evaluate the log base 6 of 36 and then multiply that by 4. So we have 4 times, well, 6, what is the exponent of 6? That gives us 36. Or you're thinking 6 to what power? You're thinking 6 to what power is equal to 36. Okay, and from here, we did our exponential equations where we have to get common bases, right? So you can think of a 6 to the x is equal to 6 squared, so therefore x is equal to 2. Or hopefully you can just understand what a log is at this point and say, okay, the exponent of 6 that gives us 36 is going to be 2. And then we just have to do 4 times 2, which is 8. So the 4 times the log base 6 of 36 is equal to 8. Letter C says the log base 4 of 1/16 is equal to what? So we have to evaluate this. What is the exponent of 4 that gives us 1/16? So in your minds, this one might be a little bit tougher to do in your head. So you're going to say, all right, 4 to what power, so we'll put an x, because we don't know what the exponent is, that's what we're solving for, is equal to 1/16. And hopefully when it's in exponential form like this, you can see, oh, wait a minute, we kind of did questions like this last week when we were solving exponential equations. So in order to do that, we have to get common bases. So this is 4 to the x is equal to, well, this is just 16 to the negative 1. And hopefully, if you were confused, that once I wrote it like this, you said, oh, okay, I see what to do, right? Because we did this. So 4 to the x is going to be equal to, well, 16 is 4 squared, and that's to the negative first power. Okay, 4 squared is 16. That's being raised to the negative first power. And then power raised to a power we multiply. So I just ran out of room. I'm going to write it up here. We get 4 to the x is equal to 4 to the negative second power. So we could say that, okay, that just means that x is equal to negative 2. So we evaluated log base 4 of 1/16 is going to be negative 2. Because, again, log just means what power. That's why we introduce it that way. What is the exponent of 4 that gives us 1/16? Well, if it gave us a fraction, you know you have to have a negative exponent there. That's the way we go from a base that's an integer into a fraction. So there you go. We have 1/3 log base 3 of 27. So just like the second one where we had 4 log base 6 of 36, we're evaluating the log base 3 of 27 and then dividing it by 3, which is multiplying it by 1/3. Those are the same thing. So we're going to have 1/3 times, well, what's the exponent of 3? That gets us 27. 3 to what power is equal to 27? That's what you're thinking in your mind. 3 to what power is equal to 27? Hopefully you can see that that's 3, because 3 times 3 is 9, times 3 is 27. So we just get 1/3 times 3, or 1/3 times 3 over 1. The 3's reduce, and you just get 1. Those are reciprocals, and when you multiply reciprocals, they reduce to 1. For E, it says log base 3 of 81. So you just got to think, what is the exponent of 3 that gives us 81? Or 3 to what power is equal to 81? And that's 3 to the 4th power. Letter F, log base 5 of 125. What is the exponent of 5 that gives you 125? And that's 3. 5 to the 3rd power is 125. All right, for G, we have log base of 1/2 is equal to 1/4. So just because this one has fractions in it does not automatically mean we're going to have a negative exponent. We automatically have a negative exponent when it's a whole number as a base and a fraction as what's called the argument. But here, you're thinking, what is the exponent of 1/2 that gives us 1/4? What is the exponent there? So 1/2 times itself is going to be 1/4. So that's why x is equal to 2. All right, this just means 1/2 to the 2nd power is equal to 1/4. And for our last do now, we have log base 7 of 49. This should be a very easy one. What is the exponent of 7 that gives us 49? And clearly, that answer is 2. All right, so now we went over how we convert back and forth between exponential form and log form. Let's now see how we have to use that exact skill in order to solve these logarithmic equations. Okay, so our first example is log base 5 of x plus 1 is equal to 2. Now, there's no one specific way to solve log equations because it totally depends upon where our variable is. And we've got 3 different places that our variable can live. One, it can live in the base, it can live in the argument, and it could live in what it's equal to, which is the exponent. So, depending on where it is, it totally will change how we solve it. So, they all pretty much start the same way, though, is that we have the log base 5 of x plus 1 equals to 2. What do you think we're going to have to do in order to solve this? What would make sense for you to do? Think about what our do now was, why we're leading into this. So take a minute and think about it. All right? Hopefully you paused it and you thought about it and you said, well, what if we converted this from log form to exponential form? I would say very good. So we're starting with, since our log expression is on the left, we're going to start our base, loop all the way around, and we get 5 squared is equal to x plus 1. And you say to yourself, oh my God, this isn't bad at all. This is just 25 is equal to x plus 1. And I can solve for x there, right? I just subtract 1 from each side, and I get that 24 is equal to x. And there we go. So I converted it from a log expression, log equation, into an exponential equation and solved because we just did a whole week's worth of work on solving exponential equations. What about if our variable is in the base? If I have log base of x, base x of 8 is equal to 3. How can we figure out what that x is? What, in your mind, you're thinking what to the 3rd power is equal to 8? Oh, we have a visitor. Hi, Serena. Hold on, guys. Sorry, she's watching Trolls World Tour and was scared of a character. So we got log base x of 8 equals 3, like I just said. You're thinking what raised to the 3rd power is equal to 8? Hopefully that's enough where you can figure it out in your mind. But we need to, again, convert this into exponential form. And we get x to the 3rd power is equal to 8. Okay. Now, how did we solve these equations when we had a variable raised to an exponent? If you remember, what we did was we raised both sides to the reciprocal exponent. All right, the reciprocal of 3 is 1/3. So we raise both sides to the power of 1/3. What that's going to do is that's going to completely wipe out our exponents on the left-hand side because 3 times a third is 1, and we just get x is equal to x to the power of 1/3. Well, that just means x, 8 to the power of 1/3. That just means what's the cube root of 8? That's what 8 to the 1/3 means. And 2 is the cube root of 8. And that's why this is x equals 2. So you can see just from the first 2 examples how the location of the variable is going to is going to change the method you use to solve the problem. We're going to convert them into exponential form every time, but once it's in exponential form, the location of the variable will drive us in finding the method we use to solve it. What if the variable is in what the log is equal to, which is the exponent? This is example number 1 from your worksheet that you're going to have to work on yourself. So we'll do this one together. So we've had one where the exponent was in the argument, one where it's in the base, and now one where the variable, I've only had 1 cup of coffee so far, where the variable is in our exponent. So just like before, we are going to do our spiral. We get 2 to the power of 3x is equal to 32. So now we have this type of exponential equation where our variable is up in our exponent. So how do we solve these? If you remember, the way we solved these was we got common bases, dropped the bases, and set our exponents equal to each other. So between 2 and 32, guess what their common base is? 2. So 2 to the 3x equals 32 is 2 to the 5th power. 2 to the 5th power. So from here, since we've got bases that are the same, we drop the bases and we set the exponents equal to each other. We just get 3x is equal to 5. So therefore, x is equal to 5 over 3. And that's your answer there. All right, last one I'm going to bore you with today is if we've got it set up like this. What if we have one log equals another log? Log base 3 of 2x minus 3 equals the log base 3 of x plus 7. Take a minute, pause this. See if you can figure out what we do here. We can't exactly convert this, can we? So just think about what you know, right? Remember, logs are exponents. So think about what we know about our exponents. So pause it. Think about it. All right. Welcome back. Hopefully you thought and you said, well, wait a minute. If you look, both of these have a base of 3. So I remember in solving exponents, right, there's a reason why I just went over question number 1 with you, is that when our bases are the same, we can drop them and set the exponents equal to each other. Well, the same rule applies when working with logarithms. Since both of these are log base 3, then what we're allowed to do are drop the log base 3s and set our arguments equal to each other. So for here, we just get 2x minus 3 equals x plus 7. Because those are the only things that are different. So if these two expressions are equal to each other, then we only care about the parts of the expressions that are different, which are these arguments. So we just solve for x like we normally do. This is just a linear equation, pre-algebra. Subtract x from each side. We add 3 to each side. And we get 2x minus x is x. Those cancel out. Those cancel out. 7 plus 3 is 10. So we get x is equal to 10. So, as Darth Vader says, that is all too easy. Very easy, not a problem. Just work it out and you can do it. So this is the end of today's lesson. I hope you understood it. If not, reach out to myself or Mr. Fallett. We'll try to explain it further. If we can't do it, I'll point you in direction of some more resources online that you can use. But don't just say, I don't get it, I give up. Reach out to us. I'm sitting at home. We could do this. For your answer key, I finally figured out a way I can get your student teacher, Mr. Bernard, involved. He's going to make the answer key to this assignment. So work it out, and it will be posted on Thursday along with your new lesson. Have a great day, guys.